Okay, hi Year 12. Moving on to the next part of the chapter, which is exercise 2C, and what it looks at is curve sketching. It's basically a curve sketching menu, which will step you through how to graph a whole heap of functions. And when looking at the function, you may not know to start with what it's going to turn out like, but we'll get those steps and we'll have a go at that. We're not really learning anything new. We're just basically bringing in the last couple of lessons, looking at your horizontal vertical asymptotes, looking at what happens as you move towards those asymptotes, and looking at the sign of the function. And that should be enough information to get us to draw the graph along with our x and y intercepts that we've used before. So what you can see up there is a list of things that in dot point that we need to do in order to sketch a graph. So we want to combine any functions using a common denominator and then factor the top and the bottom as far as possible. So we want to neaten up our function so that we can work with it. Figure out what the domain is. So that would let us look at the bottom line of the fraction, if there is one, to see what we can't do. So because we can't divide by 0. Looking at the function, whether it's odd or even or neither, might help us figure out, well, does it reflect around the y-axis? Does it reflect around the x-axis? We always find x and y intercepts. Even in year 11 we did that. We're also going to look at vertical and horizontal asymptotes. And we're going to do the same things as we did in the last couple of lessons. So let's jump in and have a go. Okay, so here's our first example down here. It says to sketch y equals 1 over x squared plus 1. So let's see what we can do. Okay, so the first step here says combine any fractions using a common denominator. Well, that's already done. Can we neaten this equation up in any way? We can look for difference in 2 squares on the bottom. Is there anything we can do? No, there's not. So at this point, we're going to leave that as it is. Okay, so our second point to have a look up here, it's saying what is the domain of our function? So that's what we're looking at, the bottom of our fraction, the denominator. It can't equal 0. So we know that that can't equal 0. So we've got x squared plus 1 cannot equal 0. So if we were to rearrange that, we'd get x squared is equal to minus 1. X is going to be equal to plus or minus the square root of minus 1, which we can't do in this level of maths. It's an extension 2 style question. So in that case, there's no restrictions on our x. And if you have a look at that up here, we're squaring whatever we get and adding 1. So we're never going to get a negative on the bottom. We're always going to get a number that's 1 or bigger. So we're going to be okay. So we would say that our domain is, for x, is all real x. So that helps us out a little bit. We know we're going to be using all the x-axes. Let's have a look at the next point. Is it odd or even? Okay. Remembering the definitions of odd or even. Okay. If a function f of minus x is equal to f of x, then it's even. And for odd, we said that f of minus x is equal to minus f of x for an odd function. So let's test that by popping f of minus x into our function and see what we end up with. So y is going to be equal to 1 over minus x all squared plus 1, which is equal to 1 over anything that's negative squared is itself squared. So minus x squared is going to be x squared plus 1. So what we end up with is it equaling to f of x. So this means this is an even function. So that helps us as well. We know we've got all of x in our domain and we know that it's even. So it's going to reflect about the y-axis. So just write that in. That's what even means. Okay. Let's have a look at x and y intercepts. Okay, so where does that happen? So y-intercepts happen at x equals 0. So let's pop x equals 0 in. Y equals 1 over 0 squared plus 1, which is 1 over 1, which is 1. So we get a y-intercept at the point 0, 1. What about an x-intercept? X-intercepts happen at y equals 0. So if we pop y to 0 and we end up with 1 over x squared plus 1. If I just multiply both sides now by x squared plus 1 to get rid of that on the bottom line, these will cancel. On the other side I'll get a 0. 0 equals 1. Well, that's not true, so we're not going to have any x-intercepts. Okay. What's our last thing we need to do on our list? Okay, vertical and horizontal asymptotes. Well, when we're figuring out the domain and looking at that bottom line, which is what we did at the start, because we know we can't divide by 0, that's giving us our vertical asymptotes if we had any. So we didn't have any vertical asymptotes in this case, but let's have a look at our horizontal asymptotes. We did those last lesson, so we should be fairly confident with doing that now, hopefully. So in doing our horizontal asymptotes, we're dividing by the biggest power of x on the denominator. So the biggest power of x is x squared, so I want to divide everything by x squared. Let's neaten that up a little bit. The 1 on x squared will stay there on the top line. On the bottom line, we're going to go 1 plus 1 on x squared. And what we're looking at here is what happens to y as x goes to plus and minus infinity. We can do x going to infinity and x going to minus infinity separately, but in most cases, that's going to give us the same outcome. Okay, so as x gets really, really big, on the bottom here, x gets really, really big, 1 divided by a really, really big number basically goes towards 0. So we're going to have 0 over 1 plus 0. So that's going to be 0. So y is tending to 0 as x is going to infinity. So y equals 0 is a horizontal asymptote. And we can have a look at what happens to the graph in a moment around all these points that we've looked at. So we've done all these points up here. Let's draw our graph and see what it looks like. Now, before drawing that graph, what we could have done earlier on, or probably should have done earlier on, is have a look at the sign of the function around any important x points here. The reason I didn't do that, but we normally would on a graph if we can, is if we had asymptotes in the vertical, so that relating to x. I don't have any of those, and I also don't have any x-intercepts or zeros to check. So in this case, I can't actually work with the sign of the function here. But what I can have a look at is down here, looking at our horizontal asymptote, which is y equals 0. I can have a look at what's happening as we get closer to that. And we'll do that on the graph. So I've just quickly drawn up an x and y axes. I popped in my horizontal asymptote. I popped in my point here that it cuts the y axis, which is, we found up here is, which is 0, 1. And I found out here when I tested for my horizontal asymptote, which is the x-axis, that x went to infinity and y went to 0. When x went to minus infinity, y went to 0. So we know we've got a cut here, and we know that as x goes to infinity down here, y is going to come down. So we're going to go down here like this. And we're going to have the same happening on the other side. Now remember we tested back here and we said that it was even. Right back here we tested it was even. So what we have happening on this side is also going to happen on this side here. So we're going to move down here like that. And that's kind of what our graph's going to look like. Let's have a go at another one and see how we go. So our next one is over here. Okay, so let's grab another colour and zoom in a little bit. Okay, so let's do those same things that we've just done up above on this one here. So the first step was see if we can neaten up this graph. This function, sorry. So what I can see on the bottom line is it's a difference of 2 squares. So I'm going to pop that in to start with. I think that's really good to pop those in and we can easily read off information. The second point was to have a look at the domain. So we know we can't divide by 0. So this bottom line here cannot equal to 0. So we can't have x minus 1 times x plus 1 equaling 0, which basically means x minus 1 can't equal 0. And x plus 1 can't equal 0. So we get x not being able to equal 1 and x not being able to equal minus 1. So our domain would be all real x except x equals 1 and x equals minus 1. And they're going to be our vertical asymptotes. And we'll look at those in a little bit in a second. Now let's have a look at what else we had to have a look at. What was our second point? We'll go back up here. So we've done combined the fractions, we've looked at the domain. Let's figure out if it's even or odd. Okay, remembering we're testing f of minus x. We'll see what happens there. See if it's even or odd or neither. So let's do that. F of minus x is going to be 1 over minus x squared. Just popping it in here. Minus 1. So we'll end up with 1 over minus x all squared is just x squared minus 1. So what we end up with is it equal to f of x. So we have an even function. And that will help us with drawing it. So if we can get one side right, we know that we can mirror that on the other side. Because remember, even functions reflect about the y-axis. And that's really important. The next thing we wanted to have a look at was our x and y intercepts. And when we've done that, we can have a look at the sign of the function, figure out where it's positive or negative. Okay, so x and y intercepts. So our x intercepts happen at y equals 0. So we'll pop a 0 in for y, and we'll pop the rest of our function in. I might just pop it in the factored form there. If we multiply both sides by x minus 1, x plus 1, we're going to end up with 0 equal to 1, which is not true. So we don't have any x-intercepts. Let's call them ints for short. Y-intercepts. When does our y-intercept happen? When x is equal to 0. So into our function, we'll pop x equals 0. So 1 over, let's just pop it in the factored form again. And we'll end up with, bottom line being 0 minus 1 is minus 1. 0 plus 1 is 1. So we'll end up with 1 over minus 1, which is minus 1. So at 0 minus 1, we're going to have an intercept. Let's just move over here and have a look at the sign of the function, looking at all those points and see what we can find out. So we've got x, we've got y, and we've got the sign of the function. So what points have we got that we want to have a look at? We want to have a look at, well, there's no x-intercept, so there's none there to have a look at. Let's have a look at what happens around our asymptotes, which we said were, right at the start, 1 and minus 1. And let's pop in x is minus 1. Let's pop in x is 1. Now, there's no y for that, and there's no sign. Because they're an asymptote, they're not touching. So we want to find points either side of these. We're going to go minus 2 down here. We're going to go 0 in the middle. And we're going to go 2. So if we pop in values for y into each of those, we'll get our values for y, and then we can figure out what the sign is for those. So I'm going to pause it, work those out, and pop the values in for you. Okay, so I'll pop the values in here. When we popped minus 2 in, we got 1/3 out, which is positive, so our sign is positive. At 0, I got minus 1, which is a negative, and at 2, I got 1/3, which is positive. And what you will notice is the values for minus 2 and 2 for x, we get the same function or y value, which is what we would expect because we have an even function. So we would expecting it to mirror itself around the y-axis. Okay, now next thing that we needed to have a look at were our vertical and horizontal asymptotes. So now we've done our horizontal asymptotes, haven't we? We've done that. That was our ones we figured out right at the start, okay, that x can't equal 1 and x can't equal minus 1. So x equals 1 and minus 1 are our vertical asymptotes. But we can do our horizontal asymptotes now. So let's do that. Let's scroll down a little bit. Okay, so what we're doing to find our horizontal asymptotes is we're dividing by the biggest power of x on our bottom line. So we're going to be dividing by x squared. Let's do that. So our top line stays 1 over x squared, and our bottom line becomes 1 minus 1 over x squared. And we're going to have a look at what happens as x goes to positive and negative infinity. What happens to y? So as x gets really, really big, on the bottom here, 1 divided by a really, really big number goes to 0. So we're going to get a 0 divided by a 1 minus 0. So 0 and 1, it's still 0. So as x gets really big, y goes to infinity. So what that means is y equals 0 is an asymptote. As x gets really, really close, but never quite there. Okay, let's see what we can do next. Another thing I forgot to have a look at was what was happening when we moved around our vertical asymptote. So as x was going to 3. We had, where are, let's go back and have a look again. Sorry, not 3. 1 and minus 1 they were. Sorry, I'm looking at another question. As x was going to 1 from the negative side, and x was going to 1 from the positive side. We want to have a look at what's happening as x is going to minus 1 from the negative side, and x is going to minus 1 from the positive side. So if we're going towards 1 from the negative side, we've got a number slightly bigger than 1. So we want to try a number along the lines of I'll say 0.999. So a number that's really close towards 1. What's happening there? So if you want to quickly sketch that graph, that's what we're doing here, is we're seeing what's happening as x goes towards 1 from the negative side. So what's happening as x moves up here, gets close to 1 from our negative side, what happens to our graph? So if I pop 0.9999 in there, I'm going to get 0.999999 squared minus 1. I'm going to divide 1 by that. So I'd probably just try putting that in your calculator, but what you'll end up with is we'll get a number that's smaller than 1 squared, take away 1. So we'll get a negative on the bottom line, but a really tiny number. So 1 divided by a tiny, tiny negative number means we're going to get a negative infinity. So what's happening in here is we're going towards negative infinity. So I've just popped that bit on the graph down here. So as we were going towards 1 from the minus side over here, our graph went to negative infinity down here. We know our graph is even, so it's going to do the same on this side. So I'm going to draw it in, but we're going to also check it. So if we were moving towards negative 1 from the positive side, so going towards negative 1 from the positive side, that's this bit down here. We want to figure out, well, what's happening? And it's going to go down here, but let's see. So we're going towards negative 1 from the positive side. So we want a number that is along the lines of, minus 0.999. So a number that's really close to 1, but it still sits this side of it. If we pop that in to our function here and see what happens, we're going to get a value that is less than 1. And we take it away from 1, it's going to be a negative. So 1 divided by a really tiny negative number is going to give us a massively large number that's negative. So that's what that's going to happen. We're going to head towards minus infinity. Now, we've done this part. We need to have a look at what's happening here and here. I'm going to try this one over here. And what you'll find is it's going to be mirrored on the other side because we found our function was even. We can test both, but let's do this one over here. So I want to see what's happening as we get towards 1 from the positive side. So this bit here, getting towards 1 from the positive side. So we want a number that's a tiny bit bigger than 1 and see what's happening right there. Is it going to shoot off up here? Is it going to shoot off down there? And we'll also have a look at the sign of the function as well. It could go down here. So we want 1.0001. And we'll try that one out in our calculator. So if we pop that in our calculator, it's going to be slightly bigger than 1. So we're going to have a positive value, but it's going to be a tiny value. So if we go 1 divided by that tiny value, it's going to go off into infinity. So y is going to go to infinity down here. We should also be fixing that up, that graph. I'll just zoom in a little bit with this part up here. And that'll tell us the same thing. So we know 1 was an asymptote. When we're at a number bigger than 1, we were positive. So we're up here. That's how we know that it's up here going to infinity and not down here going to infinity. So we're going to be moving up like that. Oops, that's not a great graph. We know when we're at 0, we're at minus 1. So we've got that. And we were negative there. We know when we're at 2, we were positive. So down here, we're going to be positive as well. And that's going to mirror this one. And we're going to be moving along here like this. There's a lot of things we can bring in together to get our graphs. And we need to look at all those things to give us information to be able to draw it. So there's our graph. That's what it looks like. It's a little bit different to what we've seen before. So you're not always going to know what a graph looks like before you get into there. But I think a lot of practice is going to make you feel confident that you're going to be able to come up with graphs like this.